Let us understand how the resultant stress equations are represented for the compression phase and the tension phase for the pre-stressed concrete beam. Let us consider a concrete beam which is to be pre-stressed by a tendon. So in the first figure, this is the figure 1 where I am showing. It is the figure number 1. So let us consider that we are trying to pre-stress it eccentrically, which means we are going to pre-stress it at a distance of E from the neutral axis. So let us assume that this is the neutral axis here, and below this neutral axis at a distance of E, we are going to pre-stress with the cable. So this black color line, whatever you are able to notice, this is referred to as tendon. So we are trying to pre-stress with some eccentric distance. So while considering the pre-stressing phenomena or pre-stressing process, the stress which is generated entirely due to the pre-stressing is designated by P by A, which means the sign convention for the compression is considered to be positive and the sign convention for the tension is considered as negative. Since here the concrete we are we are trying to pre-stress for a concrete beam, concrete is very much strong in the compression, so the general sign convention considered for the compression it is positive. Okay, and therefore the pre-stressing which is developed completely due to the pre-stressing action, it is taken as P by A. So this is nothing but it is the direct stress which is developed due to the pre-stressing process or the phenomena. And next, soon after pre-stressing, the tendon tries to bend in this upward direction, as a result of which tension is expected in the top fiber of the beam and the compression is expected to occur in the bottommost fiber, as a result of which in order to account even for the eccentricity as well, the pre-stressing, the stress which is developed due to even bending is given by P by ZT, which represents, that is with respect to top fiber. T represents with respect to top fiber and here it represents ZB. It is nothing but bottom fiber. So here the sign convention negative is taken at the top. Okay, it is because the sign convention considered for tension is negative and compression it is positive. Since here in this beam compression is acting at the bottom, the sign convention consider it is positive here. And soon after subjecting it to the loading, soon after subjecting this into the loading, what happens? This beam tries to come back to its original position, just like shown in this sketch. Okay, and this is figure 1, this is figure 2, this is figure 3, and lastly this is figure 4. When the beam is pre-stressed beam is subjected to the action of external forces, the beam tries to comes back to its original position and thereby the topmost fiber experiences compression and bottommost fiber experiences tension here. And again the stress expression by considering pre-stressing plus self-weight is given by plus mg by zt and at top and minus mg by zb at the bottom. Minus is because of this tension, plus is because of this compression. And similarly when it is subjected to the additional live load, as in the case 4, as in the case 4, when it is subjected, it can be noticed here in this beam, we are able to notice that pink color, this is the reinforced, that is tendon, and due to the application of external force like this, the beam tries to become entirely flat here, and again the compression is expected at the top fiber and the tension is expected at the bottom fiber, as a result of which the stress expression for the condition pre-stressing plus self-weight plus live load is given by plus mg by zt at the top plus is because of the compression is expected at the top, and minus is because of the tension is expected at the bottom. And therefore, for the simply supported condition, the final expression, that is resultant expression, F superior stands for the topmost fiber, inferior stands for the bottommost fiber. By combining all the previous expressions, the first condition is P by A, second condition is minus PE by ZT and plus mg by ZT, third condition, that is due to the self weight, and lastly this is due to the live load plus self weight condition at the superior, whereas F inferior is considered P by A plus PE by ZB minus mg by ZB minus mq by ZB. So this is how we get the final resultant stress expression. But as far as the cantilever condition is considered, we know that the cantilever beam experiences tension at the top, compression at the bottom, as a result of which the pre-stressing concept and the resultant expression also varies here. So you can notice here in the expression of the simply supported condition, F superior, here it is plus P by A plus P by A. Since you are pre-stressing it at the initial phase, both are compression in nature, both are positive. But as far as the bending is considered, the sign convention changes. Here it is minus, here it is positive. And also with respect to dead load, the sign changes here, plus and minus. And here live load, here it is plus, here it is minus. And similarly, it is for the F inferior as well. P plus A plus and P by A remain same here, and here PE by ZP, and here it is minus PE. And again, in the case of F inferior simply supported condition, it is minus mg by ZB, here it is plus mg by ZB, and finally this is again minus mq by ZB, and this is plus mq by ZB. And this is the final expression that can be used to compute the resultant stress in the pre-stressed concrete beam.